Hi again, everyone. I wanted to go over take home number 3, problem 1, and I'm going to write it up here. Which I asked a lot of you to redo. I overestimated the fact that you know how to use the calculator, and perhaps I should have been a little bit more specific. So I apologize for that, but I'm making this video so I could show you exactly what is expected on the AP, step by step. The whole idea is that a long answer question on the AP should not take more than 15 minutes. We only have 15 minutes to do it. So you're not expected to spend an hour doing the problem. I mean, now in the beginning, you might spend maybe 20 or 25 minutes, but it shouldn't take more than that. So I'm going to go over what we should write down and how much the calculator comes into the situation. So let's review the question. It says that the domain of the function is the set of real numbers, and we define g with selected values here and its derivative, and we're given this chart. So we have this chart for g. And then they also define this other function, f of x, which is much more complicated. You're not expected to differentiate this by hand, and you're not expected to write out its derivative by hand, even if the calculator does give it to you. We'll go over this, but I'd like to show you what you're expected to write down. In part A, it asks to use the values of g from the table to estimate the derivative of g at 5. So here what we do is we have to find the average rate of change of g. So it's approximately equal to the average rate of change of g in an interval that includes 5. So that interval would be from 4 to 6. So that's simply the slope of the secant line. It's the closest we could get to the slope of the tangent line. That's g of 6 minus g of 4 over 6 minus 4, which gives us 2 minus 5 over 2, if we look it up in the chart, and the answer is negative 3/2. So that was very straightforward. Do not use the equation of the tangent line here. The equation of the tangent line is used only to approximate the value of a function near the point of tangency. If we have to approximate the derivative, we use average rate of change. Okay, so let's continue. Now, in the second problem, we have to find the derivative of r at 2 if r is defined to be f of x minus g of x. So let's take a look at that. So now, all we have to do is write down that the derivative of r, because it's the difference of two functions, is the derivative of f at x minus the derivative of g at x. And now we replace 2 for all the x's. This is all we need to show the reader. The rest is done on the calculator. And note that the derivative of g at 2 is minus 4. So we're going to have the calculator evaluate the derivative of f at 2 and round it off. And the answer to this comes out to be negative 0.6448. And I will show you how to do this at the end of the video. All right, now for the next part, we're supposed to get the derivative of s at 4 if s of x is defined to be f of x times g of x. So all we need to write on the paper is that the derivative of s, using the product rule, is the first times the derivative of the second plus the second times the derivative of the first, and then we substitute a 4 for all the x's. And we could fill in the values for g. We know that the derivative of g at 4 is 1, but we don't know f of 4. And we know that g of 4 is 5, but we don't know the derivative of f at 4. So we're going to do all of this work on the calculator, which again I'll show you at the end of the video. And after we do the work on the calculator, the answer is 24.55. Now, in the next problem, we use the quotient rule. So we have to find the derivative of t at 6, where t of x is defined to be f of x over g of x. So first we use our quotient rule and we write the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And we substitute our 6. So we have g of 6 minus the derivative of f at 6 minus f of 6 times the derivative of g at 6 all over g of 6 squared. We know that g of 6 is 2. And we know that the derivative of g at 6 is negative 3. All over g of 6 squared, which is 2 squared, or 4. Now, we'll enter this into the calculator. I'll show you how to do that. And the answer here was negative 6.485. And that's all we need to write. Nothing else. All right, now please watch the video to see how we get these answers on the calculator. And I show you little tricks, so please watch it. Hi everyone, I wanted to show you how to use the calculator in a long answer part of the AP. And I'm going to go over take home number 3, the first problem. All right, so the one that I'm asking you, a lot of you, to redo. Okay, so in part B, we're supposed to evaluate the derivative of f at 2 minus the derivative of g at 2. So the first thing we'll do is we're going to define f. But before I do that, we'll go to our home screen and make sure we're in radian mode. So we'll go to the right and go down to settings, press enter, and then we'll go to document settings, press enter, and make sure you're in float 8. And if you're not, you could press this right arrow and do that. And also radian mode. And if not, you could press the right arrow and highlight it and do that. We're always in radian mode, and press OK to save it. Okay, so now let's go back to our home screen. And now the home screen with the calculator, not the calculator scratch pad, but the icon that has a 4-function calculator. So we go to menu and we go to actions and we hit define. And here we can define complicated functions. So we have f of x equals x times, and if there is multiplication or division, well, if multiplication, I always put the times the sign. So I go to the trig key and I hit sign, and the square root, so it's control square, and I type in 3x up arrow 2, go to the right to get out of the exponent, plus 5. And that's f of x. Go out of the parentheses and press enter. So our function knows that f of x our calculator knows that f of x is this function, and we could find the function at any point. We could get the derivative of the function at any point. So let's go through this. So in part A, We're supposed to get the derivative of the function at 2. So to do that, we will not differentiate the function at 2. We go to menu, we go to calculus, and we hit derivative at a point. Okay, and it's going to ask us, what's the variable x? Sometimes our variable might be t, whichever way you define your function. And we want the derivative at 2. So we press 2 here. Oh no, x is here, 2, oh, got it reversed. X is here, 2 is here. And we want the first derivative. So I'll leave it. And we press OK. So here, notice the calculator sets it up for you. We have to type in the function we want. So it's f of x. Okay, now if I press enter and go outside, if I press enter, I'll get this. Do not copy this. Some of you copied it. Don't risk copying and making a mistake. So I'll go up and I'll press enter again, but this time I want an approximation. So I do control enter. And this is the approximation for the derivative of f at 2. So if I take this, highlight it, and subtract 4, because that is the derivative of g at 2, and press enter, I round off this answer correct to 3 decimal places. So the answer to part A is negative 6.448. I always truncate the rest. I take the first 3 digits as they appear. So that's the answer to part A. Now for part B, we were supposed to use the product rule. And the product rule began with the derivative of f at 4. So let's get the derivative of f at 4. So again, we go to menu, calculus, derivative at a point, and I want the value at 4. Okay. And now I want the derivative of f at 4. And I go to the right, your cursor should go to the right, and press enter. Again, I get the exact value. I go up and I press enter and I do control enter. And this is the approximation. Now do not round this answer. So now we're going to use the product rule. And this is how we're going to do it. I'm going to write the derivative of f at 4. So I go up to this and I highlight it. Times 5, which is the derivative of g at 4. That was in the chart. Plus 1, which was the f at 4. Oh, I'm sorry. The derivative of g at 4, which was in the chart, times f at 4. So I'm going to type in f of 4, right? That's all I need to do. And I press enter. Now, actually, I'm going, and I go outside, of course, but I don't want the exact answer. So I'll do control enter. And this is my approximation, 25.455. And that's my answer, 25.455. I don't need to show the value of f at 4, right? Because the calculator does it. So I carried everything down and we round off to the end. So the answer to part B is 25.455 to be exact. Some of you got 0.454, which technically is incorrect and we would lose the point. That's because we rounded off too soon, either in the derivative or the value of f at 4. So always wait to the end. And then finally, for part C, we were supposed to use the quotient rule. So let's look at that carefully. So the quotient rule, we substitute g at 6. Everything is at 6. So g of 6 was 2. So, but we have to get the derivative of f at 6. So let's get the derivative of f at 6. which was the hard one. So again, I go to menu and I go to calculus and I go to derivative at a point and I have x at 6 and it's the derivative, the first derivative, and I need the first derivative of f at 6. So again, I don't want an approximation, so I do control enter, and here I get the approximation. I mean, I didn't want the exact answer. So I'm not going to round this off. I'm going to use the quotient rule. So let's do it. Okay, so I'm going to set with parentheses. Okay, I open parentheses, and in the parentheses, I have g of 6, which is, in this problem, let me just double check to I get g of 6. G of 6 is 2. So I type in 2 times the derivative of f at 6. So I go up, highlight it, highlight the approximation, do not round, and press enter. Okay? Minus, okay, minus f at 6. So I'm not going to compute that. I'm just going to write f of 6 times the derivative of g at 6. And in the chart, the derivative of g at 6 was -3. So I'm going to put this in parentheses, -3, -3. Okay, there you would hit the sign, the negative that has the parentheses around it, all divided by, and it's all divided by g of 6 squared. So g of 6 squared would be 2 squared, 2 squared, which is 4, right? Okay, now if I press enter, that is the decimal that will truncate. And I get -6.4851. So the answer should be -6.485, period. If you wrote -6.484, we'd lose a point because we must have rounded off the f of 6 or the derivative of f of 6 too soon. So we carry it down to the very end. And that's how we use the calculator for the long answer part of the AP. So just show the reader that you know the product rule and quotient rule, making the appropriate substitutions, and have the calculator do the rest of the work. I hope you would find this helpful. And next time, when I assign a calculator problem in the long answer, I expect you to do it this way. Okay, everyone, have a great day. Bye-bye.